Spark, it just uses the existing services on AND cluster and just runs on top of AND. And then the third approach is using the Mesos cluster. However, I told you that one of the preferred way, or at least the popular way of deployment, is basically Spark via AND. The other two things, the reason being not considered is at least the Spark standalone cluster. It's being, Spark doesn't have high availability kind of mechanism built into the Spark master. And also the other approach is basically it's not widely adopted in the industry using Mesos cluster. Also, we have noticed for an end user, it's just a matter of writing a simple application. For you as an end user, you really do not have to concern on how you are going to connect with which type of cluster, because everything will get abstracted by a class called as cluster manager, and which is inbuilt within the Spark framework. You don't need to externally implement anything else. You just worry about implementing your business logic in a driver program. And also we have noticed that in comparison with the traditional MapReduce, where you use Java and write different classes to implement map and reduce phases and then the driver class, unlike that, since Spark being developed in Scala and Scala being the functional programming language, we noticed a drastic difference or a great improvement in terms of implementing this MapReduce applications. We have seen, I think, some examples in which we noticed that we just write a simple driver application wherein you just write a map and then reduce functions within it as if you are calling a simple function. So nothing difficult. You just define your own function and pass the function to the map function. That's it. It's just like another method call. So no need to worry about writing different classes to implement the MapReduce functionality, unlike in Java's, or at least unlike in MapReduce world. Coming back here a little bit, we actually tried to understand the performance differences between Spark and Hadoop as well in detail, especially by analyzing the life cycle of an RDD. As I told you, RDD is the key data structure within Spark. In fact, the whole Spark concepts have been derived around the RDD data structure. Whichever the module we consider, almost all the modules are designed on top of RDD data structure. So that's why understanding an RDD lifecycle is very crucial. So we have seen different lifecycle stages in RDD, like creation, and then moving on to caching part, and then creation, transformation, caching, reduction, which is action. So these are different key areas which we have considered for RDD. And we have noticed that how actually it behaves. So which one of these stages is lazy, folks? Could you all please ping me over the chart window? Which one of these stages within the life cycle of an RDD is considered as a lazy phase? So don't worry, I'm not sharing any screen at the moment. I just now shared it. I'm just trying to do a quick revision, okay? Excellent. So transformation phase is basically considered as the lazy phase. So now that we understood the life cycle and how it works, what happens when you actually trigger your application on top of an RDD, how the mapper reduces functions being operated on top of the RDD. Now that we have gathered all this knowledge, let's go one step beyond that and try to understand what kind of key functions are available on top of RDD. Okay, at least some of the key functions let's try to learn today, one by one. Okay, so first start with let's say what? Okay, so I am having, let me go back here, general RDD functions. Okay, so let's start with some of the functions here. Are we all good so far, guys? Say yes or no. Are you all with me so far? Even Smiley should be fine. Okay, excellent. I think pretty much everyone is great. So let's come back to the session, folks. So I think today's session will be even very interesting, especially its combination of both understanding the technical concepts as well as implementing them. Okay, so let's focus on each and every function and try to understand its behavior. So to start with, cache function. So folks, I think I no need to reveal this once again. You all know what it does, right? After the transformation phase, as we discussed, we need to have some kind of we can actually we can persist an RDD into cache using the cache method. Collect. So this is one of the interesting functions and has limited functionality, and you should be very careful using collect function. So what this guy does, basically on an RDD, when you run this method collect, it basically takes all the distributed elements throughout the cluster and returns a non-distributed array instance for you with the given list of elements. It just gives an array back to you. So you should be very careful using this method on any RDD, especially because there will not be any parallelism. The entire RDD will be returned back to your client machine where you are running this job. So since there won't be any parallelism at all, and since it returns entire data set into one single machine where your application is running, so please try to avoid this function in the production environment. It is just used for any simple applications like you're running in a, let's say, in interactive mode. If you're running a testing your application on your local machine, then okay, otherwise it's not preferred to be used. Then count method, the name itself is self-explanatory. It just gives the count of the elements within an RDD. Count by value, it basically maps the keys and just counts the value based on a specific value. And then distinct. Okay, so distinct basically returns the distinct elements within an RDD. Then filter. So we have been using this filter function quite frequently so far. It just filters the elements based on some condition. So if the condition matches, that will be available in your resultant RDD. Otherwise, that element will not be available. Then for each method, so this is quite interesting too. You can just apply or pass a function to your for each method. So every element will be applied. So every element will, this function will be applied on each and every element. Persist method, folks. Okay. So in persist method, it is very similar to cache method, but the only difference is you can pass the storage level as well. Do you recall when we discussed about the cache, we also discussed about different storage levels like memory only, disk only, sorry, memory only serializer, disk only serializers, and then memory only 2, disk only 2. So these are some parameters we have discussed as part of the storage level for the cached RDD data structures, cached RDD instances. Okay, so you can actually pass that storage level for this persist method. So both in terms of functionality, both are same. The only difference is cache uses the default parameter. However, persist uses the user specified parameter. So you can control on a specific RDD, you can control how the storage should happen for the cached object. Sample. Okay, it just basically does the sampling on a big RDD and will return a sample set of a very less amount of lines in your RDD. And you can also pass the percentage of the sampling as well. To debug string. So folks, Do you all recall we have been discussing about one thing, the lineage of transformations, RDD, resilient distributed data set. We discussed about one key feature of an RDD, which is something like if any node goes down, it is still able to recalculate that particular piece of information of that RDD only because it has the lineage of transformations. The lineage as in how this transformation have got created, who are its parents, who are its grandparents, who are its ancestors. So all this information is actually available with each and every RDD. With that information in place, the system Spark can be able to reconstruct that missing partitions of the particular RDD. If any nodes goes down within the cluster at any given point in time. In fact, as I told, if you even set the memory level as memory only for the cached objects, then if the data structures will not fit into the memory, then some of the partitions will get dropped. However, those partitions would be recomputed on demand when you further use that particular RDD instance. Okay, because of the lineage of transformation and which is available as part of the RDD. If you want to see how you can actually, if you want to see that whole information, just invoke this method on your RDD. It will print all its history, okay, in a human readable format. Count. Of course, it's the same method. I think it's been duplicated here. Unpersist. So basically, it's also self-explanatory, right? So you put the element into cache, and you might want to manually remove it. Okay, so then you can use this unpersist method. Union. It basically you have to pass another RDD to it. So it does the union operation on the current RDD and also the RDD being passed as a parameter. It does not remove any duplicates as such in the union operation. So transformations, folks. So let's catch up about the transformations, how the transformations would look like. So since we have got enough understanding or details about the transformations, and we also know the transformations are lazy in nature, let's try to dig into the different types of transformations available. Having said that, one of the key factors of a transformation is whenever you apply a transformation on an existing RDD, it will either return another transformation with either less number of elements or even more number of elements. It depends upon the type of transformation functionality. Okay. I think this we have discussed in detail when we discussed about the life cycle as well. So now let's move on further. So then map functionality. Okay, so what is map? So it's pretty straightforward, right? This is a transformation. You pass a function to the map function. Okay, it basically yields another transformation by applying the function, map function. Filter, it's pretty much the same and is considered as transformation too. Intersection. So if you does the intersection on another data set, on another RDD, so it basically does the intersection operation on the current RDD versus the RDD passed as a parameter to this function, and then returns only the results which are actually matching in both the data sets. Okay, and then group by key. Okay, so this sounds a bit interesting. Group by key. What does it mean, folks? So let me take a notepad and try to explain this. So far, are you all with me? Say no if someone is not with me. Okay, so if you see that there is something like this, what group by will do is basically it actually groups all the key value pairs based on the key. That's it. So its output will be something like this: key 1, list of list of value 1 comma value 2, and then key 2 comma list of value 2. Are we good? Okay, it basically returns a key and then an iterable. So it's like a key and iterable. That's it. It's just like a traditional MapReduce functionality. Group by like SQL. Actually, it's not. It's not a group by function. It's a group by key. It's different, Karthik. Okay. So mapper output. It's just like a mapper output. Absolutely. Then Satish says, is it similar to bags in pig? Not. You can consider it's instead of bags in pig, the simplest analogous function is basically the mapper function in traditional MapReduce, right? So when you actually pass the map by key, reduce group by key, so it's just like returning a key and iterable values. It's just like a map function in traditional MapReduce. Okay, so this function has to be used only on the key value elements. Are you good, Satish and Karthik both? Okay, excellent. So then reduce by key. This is quite interesting. What is it? Let's see. When called on a dataset of key value pairs, returns a dataset of key value pairs where the values of each key are aggregated using the given reduce function, which must be of type VV is equal to V. So what this guy is saying is, to this list, right? Let's say if we are doing word count, let's call it as say some term Spark, and then what is the list here? List is list of 1 comma 1, and then here let's take a list of say 1 here, and then let's call this as Hadoop, for instance. So if you take this as analogous thing and then reduce by key, the function basically does the aggregation operation on these elements and returns the key value pairs. Okay, so what it does, so it basically takes this as the input and internally it does it, and also it emits the final result like this Spark and then say 2. Of course, the aggregation function depends, right? So what kind of function you pass. My assumption here is you're passing the summation operation, considering it's a word count program. So depending on that, it basically returns this value. So ideally, it is taking input as this. These are the inputs, and these are the output state. Okay. So there is no like intermediate thing. You just directly apply reduce by key. So in this way, reduce by key means you can actually skip the map phase. Okay, because it is internally taking care, so you don't worry about it. How it is partitioning, how it is doing aggregation at the reduce function, just forget about it. Okay, so you don't need to even apply the mapper function if your data is already in this form. Okay, you just apply the reduce by key, which does the aggregation. Okay. Then join method, so it's just like join, right? The simple join in SQL. That's it. No big deal. So when called on the dataset types like key comma value and key comma some other value, returns the dataset of key comma value comma w. Okay, pairs with all pairs of elements for each key. So it just gives the list of that elements, list of the values from the matching key from two different sets. Cartesian product, this is kind of a greedy operation. You see here, you have to pass another RDD to it. So when called on the datasets of T and U, returns a dataset of T and U operations. So it's basically like greedy, right? Let's say if we take the example of this, let's say one set has say 1 comma 1, then you can just say 2 comma 1, then let's call it as say 3 comma 1. If this is one set and the other set has something like this, for instance, a comma 5, 2 or whatever. Okay, it could be anything. B comma 3. So then the Cartesian product does what? It basically does the Cartesian operation. So on every pair of elements. So basically it returns one by one. I think rather than this, even if I have to simplify this, let's call it as it's a single set element, single set value. It will be more simpler for us to understand. Okay. If this is the scenario, if these are two different sets, then you get something like this. Say 1, comma A, and then 1, comma B, and then 2, comma A, and then 2, comma B, something like this you'll get. Because it's kind of a greedy operation, so it performs the whole set T to U and then returns TU. Then intersection operation, so this is kind of we understood already, so just leave it. Coil is, so this is very interesting function, folks. Let's concentrate on this. So Rehan has a question, says, how is join different than group by key? So let's see. Let's have a look into it. Okay. So the difference is, see, these are two different data sets. Okay, if you are calling group by key, how would you call? Let's say RDD1 dot group by key. That's it. There is no parameter to this, which means it is just doing grouping by operation on the existing key value pair. So this has to be like this key value pairs, and just it aggregates the values of this. Okay, let's say join RDD1 dot join of. You cannot call it like this. You have to pass RDD2 to this. Okay, there is a difference, right? So you are having two different data sets and you are performing join operations on these two different data sets. So it does the join based on the key from here, let's say 1, and then values from both of them. So values from the V1 and then V2. Both the values are joined together to you. So that's the difference. Rehan. Okay, no problem. So Coalesce function. So guys, let's come back to the Coalesce function now. Coalesce function is very important and interesting as well. So guys, do you all recall, right, what happens when you do a filter function? So let me open a pre-paintbrush to explain this. Let's say you have got, some let's say 100 partitions. Let's call this as 100 partition, blah, blah, blah. There are 100 partitions in your RDD. Then what happens is when you apply a filter function, what will this do? It basically, this is an RDD1, and this RDD1 is having how many partitions? Can you all tell me? Everyone, can you ping me over the chat window? RDD1 has how many partitions? Anil, don't worry about the code. In fact, every example we have been discussing so far, we have been, going through some examples, right? I think by now you understood the pattern as well. So I'll walk you through some programs as well in a moment. Anil, okay, don't worry about it. There are plenty of examples are waiting for us. Just that I wanted to complete all these functions in one go, and then we'll go back and we'll run some practicals on top of it. How about that, Anil? So, okay, so let's say there are 100 partitions on RDD1. So just take an assumption, Jagdish, that there are 100 partitions. Okay, I cannot represent all the 100 partitions here. And now you're applying what transformation here? Filter transformation. So what happens, folks, when you apply a filter transformation? So each partition from the parent will be mapped to the child. Okay, so each partition from the parent will be mapped to a child, right? Like this. And let me copy these two. Like this, and this is what? And this is your RDD2. Okay, this is your RDD2. So since that we are applying the filter function, will the size be equivalent here? So the size, let's say here it is 1000 records. It could be here 2 records, right? Depending on the complex filter, how complex filter you are applying. It could be 2 records, it could be 10 records, it could be 100 records in the resultant partition. Here it could be 5000 records, here it could be, let's say, 250 records, for instance. What it actually signifies is, so you are having, some partitions here, and with huge amount of data, when it get mapped to the similar number of partitions, the partitions are basically ended up having very small pieces of information as part of it, as part of the partitions itself. So this is something we can actually try to optimize. Now that there are 100 partitions, we can ask the framework to basically reduce the number of partitions and actually give me an optimal number of partitions. Okay, let's say the 100 partitions might get changed to, let's say, 10 partitions in the resultant RDD. So that's what is called as Coalesce function. So it basically reduces the number of partitions within an RDD by aggregating the data. Okay, by collecting and aggregating the data from all the partitions. Are we good with the Coalesce function? Any concerns over there? Anil, Shakti, Jagadish, and everyone else? Excellent. So let's move on, folks. Sorry, what else is there? Co-group is basically like you pass a key value and then key value from two different, and then returns the key comma iterable of value and iterable of value from this list. Two different iterables. Then now that we completed the transformations, so far whatever we discussed, join, Cartesian, intersection, coalesce, all of them are transformations and are by nature and are lazy. Now let's move on to actions. Okay, so where actions as in like reduce function, first function which returns the first element of the given RDD, and then let's say take ordered. So you can even take ordered, it just returns the first n elements, and then also you can pass the ordering as well. There is some method called as take also, which returns like x number of elements from your data set. And then count basically returns the number of elements, folks. So Karthik says, what is co-group? Okay, let me explain what is co-group. So Karthik, it is something like this. I have got, say, a comma 1, and then say b comma 1, and then say c comma 2, something like this. If I have these elements here, and then a comma 2, and then say c comma 5. So I have got key value pairs like this. Similarly, let's say another data set, if there is other data set like this. Okay, let's say it has like 5, 7, 6, 8, whatever, some numbers. So this is one RDD and this is another RDD. So this is RDD1 and this is RDD2. So when you say co-group, RDD1 dot co-group of RDD2. So what it does is basically like this: a comma list of what? List of 1 comma and then 2, right? This is list, and then list of say 5 comma 10. Okay, so it is actually doing aggregation based on the key only, assuming that it has the similar keys in both the RDDs. However, it returns two different lists like this. Okay, a comma list of this and the list of this. Is this Clear? Karthik and everyone? Are we good with core group? Okay, let's move on, folks, here. So then, yeah, so take basically returns the first n elements, and then count basically returns the actual count of the RDD. Then collect method, basically this we have discussed already. It basically returns the elements as an array. However, do not use this method on a large data structure. Save as sequence file. In fact, we have seen this example last week. Basically saves the file as the sequence file format in HDFS. For each, you can pass the function to the for each function. It basically does it just applies the function to each and every element. Sorry, these functions usually are used for kind of printing the elements and all. I know, I think someone will ask this question, that what's the difference between for each and then the map function. So usually for each kind of method is used for doing the println kind of operation. So run a function on each element of the data set. This is usually done on the side effects such as updating or accumulator variable. So I may have to take this to show you the difference. Okay, so I just taken some class. Just don't worry about what is this class here. So in order to show the difference between an RDD, just give me a minute, folks. It's trying to refresh. Okay. Sometimes my Eclipse is a bit slow. Okay. Let me check if the auto build is enabled or not. Okay, so I think it's already been disabled. So no need to worry. So here, let's say errors is an RDD, right? And errors is actually an RDD. If I say slash here, spacebar here, I should have map method. So basically, if you look at the map method, you are passing a function to it, and the return value is an RDD for this, RDD of u. Okay, so you are passing a map method. It takes a function and then it returns an RDD of u. At the same time, if I say for each, so let's see, for each is taking a function, but what is the return type here? Guys, what is the return type for each? Could you tell me over the chart window? Anand, at least could you ping me? What is the, yeah, it is unit. Do you understand now? So what does it mean? What is the difference? So basically, you can apply like println kind of functions where you do not require another transformation, another RDD, right? Sorry, it just simply does not return any RDD out of it. Okay, so Karthik, no problem. So we are just discussing about the for each function. So I was just trying to explain what is for each. So for each means map basically will return a transformation. Sorry, will return another RDD. For each will not return anything, but its functionality wise, it's both of them are same. You're just applying some function on the existing elements. Okay, so then count by key. So this is similar, right? It just does the counting based on the key and returns the count value. Then in fact, only available RDDs of type key. Okay, so then we can then see. Okay, you're manipulating RDDs. So let's I think let's finish this, maybe a couple of more slides, and then we'll get on to the actual programming part. Manipulating RDDs is quite similar to Scala collections manipulation, so it's not something different. So we actually worked on a lot of Scala programs, right, where we try to run many operations on the collection classes. It is just similar to using any other collection class. So you don't need to really worry about you need to write any external additional code to actually do this. No, it's not required. You just treat it as a collection and let the Spark worry about how to distribute your algorithm. Okay. Okay. Are we good? So here he's just talking about some of the behaviors of RDD. It should be commutative and associative. In fact, in a MapReduce itself, in order to apply a reduce function, it has to be commutative and associative functionality. Then fold by key. So this is very interesting function as well. So there is a small difference between reduce by key and fold by key. So reduce by key basically reduces, here we have seen, right, reduce by key or group by key, for instance. So we have seen like it basically returns the key and list of values. This is reduced by key. Okay, key and list of function values. But fold by key is something slightly different. It does not return the list of values. Rather, it just returns the list of key value, RDD of key value pairs. However, let's say if you want to run some aggregation functionality, then you can use this fold by key. So merges the values. So it basically merges all the values. Let's say if you are doing something like this. If you have employee table, so in the employee table you have got different employees, let's say with some department, and let's assume the department is the key here in our data set. Then if you wanted to do, if you want to find out the top salaries in each department, so you are running some aggregation function, right? Like max function here, maximum of salary per department. That's the function. So you can actually use fold by key to do that. You can't use reduce by key. Instead, better go with fold by key, where it does the aggregation function and the values and returns only one single value rather than returning the list of values. That's it. That's the only difference. And reduce by key, it's basically okay. Parallel version of the reduce that merges the values for each key using the provided function and returns another RDD. Then group by key, so groups the elements by key and returns the RDD, and then sequence of key value pairs. Okay, so Shakti says, okay, map by key. Okay, so reduce by key is a key and the aggregation of the values, correct? So let me see, maybe I have flipped the words around. Let me check. Okay, yes, I think it's not really a list of values, it is just the key comma value pairs only. I think it is pretty much similar to that. So when called on a data set of the key value pairs, returns the data set of key value pairs as well, where the values of each key aggregated using the given reduce function. Okay, so there is slight difference between, yeah, it's also returns the key value pairs only. It's not a list of values. I think I probably have flipped here with group by key and reduce by key. Okay, so I think reduce by key and fold by key are pretty much same, but the only difference here is, so you can use merges the values using the provided function, unlike a traditional fold function over the list. The zero value can be added an arbitrary number of times. Okay, so it basically it's usually used for finding out the maximum salaries from the existing departments and all. So you can do that using the fold by key. Probably you can do the same operation using the reduce by key also. Not much difference, folks. And then reduce by key. Okay, so this we have seen, and then group by key also we have seen. Lookup. So this is a very interesting function as well. So considering you have got a very huge amount of RDD distributed across the cluster of nodes, you can actually look up for a specific element. Okay, looks up for a specific element in the RDD, uses the RDD partitioner to figure out which partitions to look at. Okay, it uses the partitioner implementation to actually find out which partition should probably have the existing element you are trying to search. And then map values, a specialized version of map for pair RDD. So these are actually pair RDD functions. Okay, so this is something bit advanced on the pair RDD function. So then you only want to change the value of the key value pairs. So if you need to make your changes based on both key and value, you must use the normal RDD map function. So this is map values, and then that is the map function. And collect on this. So probably this way we discuss about pair RDDs, it would be a bit confusing. So let me introduce you to some coding part, and then let's try to get some hands on that. Based on that, we try to understand this pair RDD functions. So this also has pretty much similar functions: count by, key partition by, and then flat by values. So let's go get into the action, and then let's try to understand these functions. And double RDD functions, as in like mean, sum, variance, stats kind of functions you can apply on the double RDD data structure. Giants in Spark. So before going there, let's try to run some examples. Okay. Guys, did we discuss about Spark word count program? Did we already discuss about Spark word count? Okay, so I think it's been already discussed. So let's move on to log analyzer class. So guys, log analyzer, basically what we try to, I think this also, have you discussed on the log analyzer as well? Say yes or no. Did we discuss log analyzer class already? Okay, excellent. So we have already completed log analyzer as well, where we tried to cover mapper, filter, all these kind of functions, right? I think someone has asked whether we have actually any map function or reduce function example. So I think, does this cover, folks, for mapper and reducer functions? We have already discussed this log analyzer class where we use this filter, map, this kind of functions basically can be just applied as if you are running on a simple data structure. Okay, it's here. So let's have a look into joins class. I think there is some other word count also. Maybe let me see if it is slightly different than the existing ones. Okay, so let's not worry about it at the moment. Let's have a look into the joins. So similar to another classes, I just imported Spark context and then Spark configuration instance, and then joins here. So object joins, then I'm writing a main method in that. Then I'm instantiating the Spark context instance by passing the configuration instance to it. Then, okay, so here some guy in the class actually was asking about how we define the case classes, right? So guys, please concentrate. Let's try to understand how we define the case classes in Scala. So whenever you require some data structure, you no need to go and define that particular class separately. Instead, we can just define a case class using case class customer, okay, and then pass the customer ID and then the name. So here, these are my parameters, and then these are the types of the parameters. So this will act like a customer class for me. That's it. You just have to say case class. That's it. Case class transaction. The customer ID, store ID, and then the amount. So now I have defined two different classes, one with customer name and one with transaction. So this is how you define the case classes. And how you use it, let's have a quick look into that. So value customers is equal to sc.text file of. So I will have a file called custs. Let me show you what this customers file contain. Okay, so I have got some customer ID and then customer name. Okay, so this is the customer file data, and also I have, so what I'm trying to do with this, okay, also I have got transactions, right? Cust transactions. So let me show you what it has. So I got transactions as well, like the customer ID and then the transaction ID and the transaction amount. So this information I have in both the files. So what I'm trying to do with both the files here. So now I'm just loading that Spark context.txt file of. I'm loading that file, and then .map of. I'm writing a map method underscore dot split of /t. So it basically takes each line, splits by /t. So you get customer ID and then customer name as a tuple here. So everything will be recorded into an RDD. All the tuples will be collected into an RDD. Then what I'm trying to do here, it's basically val cust records is equal to cust.map. So I'm just taking this RDD.map function and then record of 0 to 2 int customer. I'm instantiating the customer instance here. Customer of record of 0 to 2 int and then record of 1. This will instantiate the customer instance and then will create a 1 comma customer instance and then allocates to customer records. Similarly, I'm using sc.text file to load the cust transactions here and then map.split of /t, then map of record, then record of 0 to .2 int and then transaction of new transaction of its integer, then the transaction ID and then the transaction value. So I'm actually assigning the objects with its user ID and then the transaction details. So now that I have both these RDDs, cust records and transaction records, I'm now saying println transaction records are to debug string to just show you how the lineage of transformations would look like. Okay, then cust records the join of transactions records, then join D. So it basically returns the join operation. So on both the customer records and then the transaction records, it does the join operation and returns the joined RDD. So now that I have got join RDD, then I'll just say left outer join also. So customer records dot left outer join of transaction records. So left outer join RDD, and then this is Cartesian product, and then this is co-group. So I just wanted to show you the differences between each and every operation, like left outer join, Cartesian product, co-group. So I just trying to do that, and then I'm using the for each method to print basically to print the elements. Okay, so let me say println of some delimiter here to show you the differences. Okay. Shakti says in join function, are we providing which key it should join? So you see here, the RDD should be key value pair RDDs. Okay, that is mandatory thing. And both the RDDs should have the same key. That's the condition here, Shakti. So now that you are passing that to this guy, so it automatically takes this key. See, not that one. So this key, and then this key to do the join operation between these two things. So it automatically considers the key basically. So let me call it as, say, join, and then here, what is it? For left outer join, right? Left outer join, and then what? Then Cartesian, and then co-grouped. Okay, so now that I have used all these functions, so let me build this class quickly. Okay. Okay. So Satish says, what is R of 2.2 float in transaction records? Okay. So it is a tuple. So let me explain. If you are confused in what it is actually means, let me take a notepad and try to explain you. So guys, please concentrate. For whom it is not so clear, please concentrate, guys. So have you noticed the data sets, how the data sets look like? One is customers and the other is transactions. These are two data sets we have, right? It's very clear, isn't it? What the customers data has. It has one, a tab, and then say name as Shakti. And then let's say 2, and then say Karthik. Some names, okay, I'm just taking randomly some names. Then transactions, basically like this, 1, then tab, and then 001 transaction ID, and then transaction 99.9 for instance. And then 2 transaction ID, since it's 002, and then $100. Then 3, 003, then say 104. I'm just taking something like this. It can't be 2, right? Because there is no third record. Let's say 1 for instance here. Let's say if these are the records, you know, in both of them, when you say join here, what happens is it basically does the join operation between these two records. So you have to first primarily aggregate the records, and then when you do join operation in both of these, so it looks something like this. So you have to do the aggregation first of all here. So then it will become, when you perform aggregation operation, so let's say 100 and so 299.9. And then now if you run say join operation, so then what happens is it basically returns something like, okay, so even before running join, right, what we did, so that's the question here asked by Shakti. So what we did, it's not really a tuple here, it's a record here. So this is a line, right? What is this? Customers, what is it? It's a file. Transactions is a file. And what is this, Shakti? It's a line actually. It's a line within a file. So now what we did, since line is basically a string, right? It's a string. When we created the cust records, cust RDD, which is cust records in our example, in cust RDD, what I'm trying to do, basically I'm trying to do this 1, then new customer of 1, Shakti. Do you understand this concept? So basically I'm trying to create an instance of customer, because do you remember we have actually defined a case class customer, and then customer has what? Customer has ID, then int, name, string. So since this is an integer, I have to do, okay, so in order to do this, first of all, primarily in order to do this, let me do one more step here. What I'm trying to do here is basically like this: rdd dot map of r tends to, then I perform some operation. So what is this r stands for? Let's say if I'm talking about customers RDD here, customers RDD. So this customers RDD is basically a file RDD. When I say map, what is this R stands for here? R stands for each line every time. Okay, it's a row, it's a line every time. So when it's a line, so this line is nothing but this R now. What I'm trying to do here, something like R dot split of slash t, right? I used slash t. So when I say slash t, this map will return another RDD. Let's call it as some tuple. Let's call it as some RDD2. Okay, this RDD basically have the list of tuples now like this. These are not really lines. Instead, these are tuples now because I'm already splitting them, and that split operation basically returns a tuple. So now this has this tuples 1 comma Shakti and then 2 comma Karthik, but still both are considered as string values. So in order to convert them to an appropriate value, when I do this in the third operation, right, like this, customers RDD dot map of R. So again the same thing. R stands for this tuple now. Okay. R dot underscore what? Underscore 1. So tuple starts with 1. It doesn't have 0. Underscore 1 dot 2 int, which means it basically takes this first parameter out of it and will convert it into integer. Okay. Similarly, r dot underscore 1 means first parameter here. Dot to int. That's it. You got the idea now? So it's basically a tuple. R means here a tuple here in this case, and this tuple has underscore 1 basically represents this value here, and then to int. Similarly, here when I say this r of 1, it's basically I'm representing like this first parameter, which is the integer, and the r of 2. Oh, I think this is an array. Okay, I'm sorry. Probably this is an array. So r of 0 is dot 2 int, and then r of 1 is basically that transaction ID, and here is the transaction value. Did you get the idea now, Satish and everyone else? So it's basically you are mapping each record and trying to convert them into appropriate data types and then creating that particular instances here. Okay, like the customer here in case transaction because of these classes. So that's why you're converting them into appropriate values. Okay, so now that we did this operation, so first join we understood, and then left outer join, and then Cartesian co-group. So let's try to build this class and then run it. Okay, so Anand says here for customer new is not used. No, it is not required actually. Okay, you can directly use because there is a case class. You don't need to specifically say new operator. You can just directly say customer of because it's a case class. So let me build this now. So what's the build file look like now? It's a simple .spt, right? Okay. I'm trying to build the source code. Ideally it has to build. If it has some errors, probably I'll create a new build file. Okay. Okay, so I think it has the same error. Probably I forgot to fix this issue. Okay, that's fine. Unresolved dependencies outed Apache Hadoop, Hadoop core 2.4.1 not found. Where did we use it? Okay, so probably this is the one which is creating the issue. I think let me check the repository name for this. Hadoop Maven repositories. So I'm just trying to check the right repository name for Hadoop. Okay, let me check for core. Let's say 2.4.1. I think 2.4.1 they have not given, but let me check for any one of the latest. Library dependencies. It's pretty much same. I don't know why it's throwing this error though. Ideally, they should not throw error, guys. I mean, because the Maven repository is absolutely correct. And maybe if I move this, let me remove this and see if it makes any difference. So guys, so far any questions? Are we all good? Say no if someone is lost somewhere and if you still have any questions. And feel free to ask your questions, post your questions into the chat window. Okay, still got some problem with this. Okay, this is complaining about OpenCSV now. I think last time probably I did building of this project by copying it into some other project. Scala test project, right? Okay, let me do this again. Okay, for time being, let's not waste time debugging this. Copy. Okay, so I have these classes here now. CD Scala test project. Now SPT package. So guys, I have just moved this because there is some issue, some weird issue. So just to avoid that issue, I just okay. The build is successful now. So now that the build is successful, I might get the project name somewhere here. Sorry. Target scar2.10 hello spark, this one, paste hello spark 2.10 or whatever. So let me move that to my VM. So I'm just moving the jar file to my home directory, and then let me start my Hadoop cluster first. So I'm starting my Hadoop cluster, and I'll also start the Spark cluster. Then I'll come back a little bit and I'll run the join example. Okay, and also let me show you the data. I think the data is already there in my path. I just have to run this program now. So the class name is module5.joins. Oh, I think one mistake I have done. I have to change the path here. Okay, so let me change the path quickly. So now that I have changed my path to home embellisher, so which is the right path, let me rebuild the project again. Meanwhile, my Hadoop cluster has been started. Now I'll go to Spark. Otherwise, we can directly use Spark shell. Sorry. We can run it in local mode as well. Okay. So it's already running on local mode, so better I'll use the same thing. So now the project got built. So let me move it again. So now that everything is ready, I'll just run the program, folks. So bin/spark submit class is module 5, and then in our case it is just joins, and the jar file name is hello spark, right? It's the full name of the jar file, hello-spark _2 _2. jar. That's it. So this is my jar file name. So this will pick up the files from the home folder. Class not found. Module 5.joins. What's the issue here? Sorry. The joins is there already. And then why it is saying it's not there? Am I using the right jar file? Let me delete all those things. It's kind of a bit confusing. Hello Spark underscore 2.10.2.0. Module 5.joins. Okay. Okay, it's the same jar. Joins the transaction. Okay. So the class is also there. Okay, so looks like there is nothing like the pack. Oh, okay, I understood the problem, folks. Okay, so the package is not there. It is just directly built on top of joins. I understood the reason for that. I'll explain that in a moment. Okay, so the job has been job has run, but there is some issue. It looks like. Oh, looks like this has not been replaced. Okay, maybe did I forgot to copy the newly created jar file? Okay, let me rerun once again. So Anil says your Spark home Spark submit hyphen class. Okay, is there any problem with that, Anil? Did you notice any problem with that? I don't think so. I got the problem actually. I'll tell you the problem. So now that I have this jar file, probably I have to copy the jar file again. cpmnt gfs hello Spark to the home directory. Let me now rerun it. This is interesting. Why it's not being changed? That's the question here. Even though I have changed it in the code, Let me change the version. So I'm just putting some debugging statement to quickly debug the class, guys. Okay. 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 I think I'm so terrible. Okay. So I think I have to copy this, right? I'm not moving this file here. Excellent. Okay, so I understood, folks. So let me just do this. Okay. Okay, so apologize. So basically, I forgot to copy the file. Still, there is a problem, is it? God's sake, don't tell me again the same path. Okay, excellent. Okay, let me rebuild it. Also, I have changed the version, so it takes long time to build now, but it's fine. So at least we can make sure that the code is in correct format. Joins.color. File home embellish casts. Okay. Ajay says I'm still using the same order. Oh, did I forget to copy the file from the? Okay. Sorry, Shravan and Ajay. Okay, I understood. Okay, I think probably I think my mind is not here. So today I actually watched a couple of movies, so probably I'm lost somehow. Okay. One is the movie In Time. Did someone see the movie In Time? Watch the movie In Time. It's very nice movie though. Conceptually, it is very nice. Excellent. Let me refresh this. It's here. And also they have released the Jungle Book movie, right? So Jungle Book movie is also quite good. And for children at least, they enjoy it a lot. Okay. So now, so hope there is no issue at all now. Let's see. So Shakti says he's going to watch the Jungle Book movie today. Good, good Shakti. Let's hope for the best now. Okay, so nothing happened. Okay, great. So I think now the program went successfully. Let's see the output now, track the output. Okay, where is the join? Left outer join is here. But where is the join first? See guys, so join has started now. I think I first tried to print this, right? To debug string. Did you see something here? To debug string. So it basically prints out, the metadata of that particular instance. So it says map partition RDD7 and then okay at map and then here. So this is some kind of metadata associated with that RDD. Okay. So again, coming back from there, if I show you like join operation, right? So join operation has been printed its output somewhere here. It's here. Okay, so this is the join operation, like 1 and then customer of, okay, so this. Okay, then I have got left outer join. See, let's try to understand where is left outer join. The left outer join is here. Okay, so I just filtered few records as well. Then I have got so this is also as part of the left outer join itself. Then Cartesian product. So Cartesian product is somewhere here. So it's just like greedy, right? So it's 1-to-1 mapping. So the number of records are quite high in the Cartesian product. Co-grouped. Okay, the output is somewhere here for co-grouped. This is something analogous to the bags concept in Pig. Okay. So these are different operations, folks, on 2 different art lists which you could perform. So are we good? So you guys can run this example as well in your machines and try to get some detailed understanding on what's the output and how the output has been generated from the given data set and the differences between all these functions as well. Are we good so far? Shakti, Azai, Shravan, Anil, Anand, and everyone else? Are there any questions? Okay, Anil says, can we have code and the source file? Absolutely, Anil. Okay, so you'll get both of them. Support team should upload this code in your LMS portal. I hope by now they would have already uploaded this, because as per their knowledge is concerned, I think we are still behind the schedule, right? So I hope like they already copied this file. Okay, so that's the demo on the joins. Let's move on, and then partitioner in Spark. So folks, how many of you really understand what is a partitioner and then how it works? In fact, I think when we discussed about MapReduce, we did discuss about partitioner as well. Okay, let me explain that once again quickly if someone is not quite clear on the partitioner part. So folks, what is the default partitioner available in Spark or even available in MapReduce, traditional MapReduce? What is the default partitioner? It is hash partitioner. So what is the purpose of hash partitioner? It's not hash map, it is hash partitioner. What is the purpose of hash partitioner? Okay. So the purpose of hash partitioner is, right, I mean, generally, let's first talk about partitioner. What is the purpose of partitioner? And then we understand how the hash partitioner behaves. So the purpose of partitioner is something like, let's say you are actually dealing with a large data set, and then this data set is distributed across the node. So you're dealing with a distributed data set. So when you're passing the values from the map to a reducer, in terms of aggregations is concerned, you might have to do the aggregations based on a specific key. Okay, so how will you make sure that you send the data to the appropriate reducers? So that could be controlled with something called as partitioner in MapReduce programming paradigm. So this is another component, and partitioner sits in between a mapper phase and then the reducer phase. It sits in between them and controls how the keys and values will get passed or shuffled to the reducers. Okay, here using the hash partitioner, the way it behaves is basically like this. Let's say you are having a key value pair, let's say key, comma value pair. So using a hash partitioner, right, which is the default partitioner. So this what this guy does, it basically calculates the hash code on the key, hash code of key. So once it gets the hash code, it performs the modulus operation on the number of reducers. So let's say if your reducers are 2 and the hash code is 100, modulus of 2, what is the remainder out of this operation? It is basically 0, which means that this particular key will actually go to reducer 1. Reducer 1 will actually take this particular key value pair and process it. In this way, to basically control how the keys and values will get distributed across the reducers, and also make sure that the aggregations happen on the appropriate keys. Okay, so that's the purpose of it, and that's what has been discussed over here. Multiple dataset operations and most grouping operations requires keys to be shuffled across the network for correct joining and grouping. I mean, in order to make your aggregation operations accurate, you need to use a right partitioner to it, to your MapReduce paradigm program. These operations might be very costly for big data sets, so these operations could be turned with effective using the partitioner. So if you are able to tune the partitioner, probably you could optimize the performance. Okay, you can tune the performance of your MapReduce job by choosing or by creating the right partitioner to do right work. Okay, so you are actually free to go ahead and implement your own partitioner in Spark as well. So let's say how it works. So as we've seen already, we understood, right, how the partitioner works, because I actually explained you the MapReduce programming paradigm sometime before. So I'm not going to spend too much time here. So however, the high level idea is you have the user data and you have the events data, for example. And if you say you are trying to do the join operation, the records has to be shuffled. Okay, so from each data set, the records has to be shuffled, and then the join has to be operated on the shuffled data from both the data sets. So in this case, so even join with the partitioner. So if you're doing without partitioner, it looks something like this. But if you're doing with partitioner, so what this guy means is basically, okay, in both the slides. So let me define once again what this slide is trying to convey. I mean, what is the message this slide is trying to give is basically this. When I said performance improvement, how you could achieve the performance improvement is, let's imagine a situation where you have two different data sets, and both these data sets doesn't have any proper partition. So they are just jumbled. That's it. There was no partitioner used. Then while doing the join operation, it has to do a lot of work. It has to do the shuffle process and, you know, do the join. It takes a lot of time and energy. So if you make one of your data set at least to be partitioned with a specific partitioner, and if you are using the same partitioner for the join operation, it will greatly reduce the amount of shuffle happening between at least one data set. So it has to just perform the shuffle operation on the other data set. Consider there is a situation if both the data sets are partitioned with the same key. Then it is even good, even better. Then it actually does not even has to go through the shuffle phase. Rather, it just does the one-to-one mapping of the join operation. Okay, so your data sets has to be partitioned based on some specific operation, based on the similar operation, like selecting the same key, and the type of partitioner on both the data sets will greatly improve the performance of the join operation. However, it requires some additional steps, right? Before you have to run this join operation, you first have to partition the data appropriately. So let's have a quick look into the partitioner example. So distributes based on a key hash code, correct? So all the records with the hash code will be the same partition. Okay, I think those were the explanations, not the questions. So let's me move on here and show you how the partitioner implementation looks like. So join with partitioner. So I'm just trying to have the join with partitioner class. I'm instantiating this Spark context instance. Customer transaction, it's the same story. Okay, I'm just creating the customer records, transaction records, again the same story. But the only difference here is when I'm trying to apply the map function, I'm actually passing the So I'm taking the records and then record.toInt and then the float partition by hash partitioner of 2. So I'm just partitioning the transaction records based on a particular partitioner, and also the transactions here were partitioned based on the hash partitioner as well. So it depends, I mean, how you want to do it. So in this case, I just commented this, which means like here also it's a non-partition data, and these are also non-partition data. But while doing the join operation, while creating the transaction records, I'm doing the hash partitioner and then I'm doing the join. So which signifies this operation here. So I'm trying to do this. So one set is already been partitioned with a specific partitioner and the other set is not, and then I'm trying to combine. But in reality, right, so when we actually see in reality, we all knew that by default it uses the hash partitioner as well. Okay, the first, this data set customer records also would have been partitioned using the hash partitioner. But however, the number of partitions we have not defined here, so it could be random in nature. Then left outer joins, so it's the same operations, join operation, left outer joins. The only thing is I'm just invoking this partition by method and passing the partitioner. You can build a customized partitioner as well. So if I look into the code of this, hash partitioner is from which package? So it is arg.apache.spark.hash partitioner. This implements, this extends a trait called partitioner. So you can actually implement the partitioner and write your own customized partitioner as well to control how the partitioning happens. This is just to show you how actually partitioner could be used. And then now that I have already built this project, I'll go here and then I'll run the class. So instead of joins, I'll say, what is the class name here? So I think this also I have to change, folks, because this also is using this. Okay, let me quickly do this change. So now I'm trying to rebuild the project. So Karthik says both dynamic and static partitions are supported in Spark. Okay, so what do you mean by dynamic and static partitions, Karthik? Could you elaborate so that it would be easier for me to answer your question? So now that I have built again, so let me copy this. Target for. Okay, so let me refresh this. Yep. Then copy this. And then first paste it onto my desktop and then copy it into this VM. Then now run the program. Okay, the class is join with partitioner. Join with partitioner. So output will be same. There's no different, but performance would be different because we have used the partition concept. Okay, so it's again now shouting at me. Home embellish inputs. Okay, I forgot to take out this inputs thing here. Okay. Okay, Ram says the benefit of partitioner is only for performance improvement in join operations or any other benefits. So it's not only the performance improvement, Ram. Okay, there could be some situations, some complex or compound cases, where your data may not be that clear, and the type of operation you wanted to perform may also be different. Okay, so in order to control that, you may want to use the different type of partitioner. Okay, for example, let me give you an example. Let's say if I ask you to do a range partitioning, I don't want hash partitioning, I wanted to do range partitioning. What will you do? How would you achieve with hash partitioner? So then you have to go back and you have to recreate the partitioner class, right? Okay, so then you write a different partitioner, you call it as range partitioner, and then you plug that range partitioner into your program. So which means you have a specific requirement. So the default one is not sufficient for you to be able to use. So then you go ahead and write your own partitioner class. Does it make sense? So that's another purpose. So it's basically how you wanted to control the keys to the reducers. So that's the key thing, and side effect is basically improving the performance. That's the side effect. It's because of in terms of joins and all. And of course, like one operation. So if you're doing plenty of operations, so having said that, if you use the same number of partitions and then the same partitioner in both the data sets, then it would be really very good for the program to do the efficient joins. Shakti says, I think is referring to partitions in terms of Hive. Oh, okay. So where we use dynamic partitions, which is, I understand now. Okay, so where this question is coming from. So basically in Hive, it's a different story, right? So Hive, those are physical partitions. Okay, Hive, you're having a table in the sense, it's a file only. You actually manage the partitions in terms of folders. So there the directories and the subdirectories basically help you actually create the partitions. So there you can actually deal with both dynamic and static partitions. But this is not physical partitions. There is nothing physically we are partitioning here. Here we are logically partitioning the records to be transferred to which reducer. Okay. Of course, these two concepts are related internally, right? So when you actually work with the Hive, Karthik. So when you're working with Hive, it internally uses the MapReduce, this partitioning, this reducer, this partitioner only to be able to partition the records and maintain the data in the appropriate folders. There is nothing like dynamic and static though. There are only one type of partitioning. So that will be, this kind of dynamic and static will be at the Hive level, because there you decide whether you manually want to partition the records and put it appropriate directories, or you leave it up to the Hive framework itself to how to actually does the partitioning by itself. Okay. Manually define the partitions, or you ask it. Okay, so these are the types of partition should look like. So that doesn't apply to the MapReduce programming phase, by the way. Okay, so that's the whole story. So if I think I have already ran the program, isn't it? I think I've run the program here. So it's basically output will be the same. You don't actually see much difference in terms of output, but yes, internally we just try to use partitioner logic there. Are we good now so far? Karthik, Ram, Shakti, and everyone else? Okay, excellent. So integrating Spark with Hadoop, this is not a specific concept, right? We have been seeing many examples by now, how we run with the Spark with Hadoop. All that we do is you just specify the master as --add. So that's it. Other than that, you are not doing really anything else to be able to integrate. Okay, Spark with HDFS. So Spark can use Hadoop as a storage as well as cluster manager. I mean, the cluster manager internally abstracts the HDFS Hadoop. Then, well, we will explore using HDFS as storage. We can access underlying HDFS data. In fact, we have been doing the same thing. So this is nothing different for us. Whatever the files we are reading, those files are actually from HDFS, right? By default, Spark will read the data from HDFS unless and until you manually say that you should go and look into the local file system, just like I did in the last two examples where we looked up the files from the local file system. But typically, if you don't specify that file colon slash slash slash, for example, like this one right here, if you don't specify this, it will by default go to HDFS. Or if you want to specifically say also, it's fine. You can just use the HDFS protocol here. HDFS colon followed by the host name, followed by your name node port, followed by the actual path with which you could be able to connect to the HDFS. So these are the ways, and then the RDDs will be created locally on each data node. So each data node will have its own partition of RDD. So that's pretty much we have been seeing. I mean, we have been trying so far. So there is nothing different to learn over there. Even in the Spark with ARN also, pretty much we are aware of everything. So you just read through the properties here. It shouldn't be any different. So even if I had to do it, so ARN spawns the Spark programs as ARN processes, where the application master process is actually the driver program, and then ARN child process are the Spark workers. So this basically is saying that, so ARN containers, right? So that's where each child, when you actually, whenever you're saying child, it is nothing but you're referring to a container. So each container is responsible to spin up a worker task, worker job, basically, the task, and then that will be monitored by something called as applications master. Then this integration is preferable mode because of the data size per data node is way more than the memory available to cache for the RDDs. And then on lower volumes of the data per node, launching Spark without ARN yields better results. So on lower volumes using Spark. So however, when we are saying it's a big data system, we are actually referring to large data sets. So it's better to go with ARN. So Spark and ARN example, all that you have to do is just specify the ARN-client. That's it. Other than that, there is nothing different. So Karthik, so there is nothing different. Last few slides what we have discussed is basically how the Spark applications read the data from HDFS that we all are quite familiar with now. Then how the Spark applications could be launched on ARN. So we have seen plenty of examples around it, right? Using the ARN client as the master. Okay, any questions, guys, so far? Are we all good? Please feel free to let me know, or please feel free to stop me if you have any questions. If you want, I can unmute you guys as well so that you guys can directly talk to me. Anyone? Shakti, Ram, Karthik, anyone if you have questions, please post it over the chat window, or you can ask me to unmute. I can unmute you now before proceeding further. Okay, so sounds like everyone is good so far. So let's take a few questions. So Annie has come back again. Let's see what she has for today. Then default Spark distribution can be used for ARN integration. True or false? Could you use default Spark distribution for running ARN applications? Is it true or false? Say everyone yes or no. Actually, it is false, okay, because I'll tell you why. So if you download the binary Spark package, it does not work with ARN. So you have to actually compile the Spark binaries with your underlying Hadoop ARN version. Then only it will become ARN compatible. Okay. So it is, how you actually download the source code, how you build your Spark binaries. This is nothing related to the programs or within the framework. It's basically outside of the framework, how you set up the Spark libraries to add. So it is false. So Karthik has a question. Is hash partitioner class? What does the arguments do? Hash partitioner of 2. Does it create 2 partitions? It creates 2 partitions, Karthik. Yes. 2 means it creates 2 partitions. If you pass 5 means it creates 5 partitions. However, it depends basically. It depends on the number of records you have and how it gets partitioned. Usually, if you're talking about big data applications, obviously each partition will get its own set of data. Okay, the answer is false. Then RDD holds the actual data just like any other variable. Is it true or false? Does it hold the data like any other variable? So Shakti says if we configure ARN as the default parameter in the Spark properties, will it directly point to ARN? Yes, you can do that. Okay, but however, if you want to control that flow, you can actually pass or dynamically set the property to each and every application. So I would recommend you can create the properties to your jobs and you dynamically set that property. The answer is false. It's not like any other variable, right? You are actually distributed. I mean, the data is distributed across the nodes and it has metadata of the data as well. So it's not like any other ordinary variable. And it is resilient also. It has got a lot more features. We can load data from HDFS to Spark without ARN. True or false? The answer is true. You can load it because Spark is compatible with even generation 1 of Hadoop as well, where there was no ARN at all. Which of the following methods is used to remove the data? Remove the data from cache. Is it remove, RMR, or unpersist? What is this method? The method name is unpersist. Guys, are you able to hear me? Say yes or no. Could you all hear me? Is there any issue? Okay, excellent. Spark can save the sequence files, true or false? Can it save sequence files? Do you remember? We ran this example last week. We tried to read the sequence files from Hadoop, from Spark, and also we tried to save the files as sequence files using the save as sequence file method. So the answer is true. All RDDs are partitioned by default. Is it true or false? So every RDD, is it partitioned by default, or do you need to do anything additionally to do the partitioning? So by default, so it's false. Okay, this is kind of tricky question actually. I would actually hate this question. So it says all RDDs are partitioned by default. So the question itself sounds like a bit not correct. Maybe I have to change this question. Okay, actually by default, right? So by default, RDDs are partitioned, but not partitioned on a specific parameter or in a specific way, or the number of partitions. But all the RDDs are by default, they are partitioned only. They have multiple partitions. But this question is kind of tricky. So maybe it is trying to ask that whether whether there is a specific way to do the partitioning, or maybe whether you can apply the number of partitions and all. Okay, that is not. So both of you who answered true and both of you who answered false are correct. So Ajay says, okay, sure Ajay, please go ahead with your question. So try to complete the assignments, okay, as listed here. So let's move on to module 6. So Ajay wanted me to unmute him. So let me unmute Ajay. So Ajay, you know, right? So I will actually unmute you and then I will mute myself so that there won't be any echo. You ask your question, then I'll mute you. Ajay, please go ahead with your question.
Good evening, Mahesh. Can you please go to log analyzer example in the IDE? The question I have here is when you see messages.cache, when does the messages.cache happens? Is my understanding right that when messages.filter contains mysql.count is executed, that's when messages is cached? That's my question. Or when you say the moment messages.cache, messages is cached. That's my question, Mahesh. Thanks.
Ajay, that's a good question. Okay, so your assumption is quite good. I mean, your assumption is correct. So the cache has to happen after the first time you run any action because because the transformations are basically lazy. So that's why when you run this, there is nothing which has been computed. So there is no RDD like messages. Theoretically, it is there because it will be kept in some kind of plan before it actually executes that plan. Theoretically, the messages instance is there, but physically there is no messages instance, so it cannot even cache that particular instance. So the actual cache happens only when you run any first statement like this. For example, say you run the filter operation here. Okay, now, okay, so here, when you do this, let's say count. So count is the action here, right? So when you do the actual count operation, even before we have some count operation here. So when you do this actual count, then only, oh sorry, this is online, sorry. So when you do this count here, then this message.cache will get executed, and then this messages will get persisted into cache once it gets created. Okay, is that clear, Ajay? Okay, no problem. That's a good question though. So it has to happen after it gets created when there is at least one action being invoked on top of it. So this subsequent actions here, right, like this count here. So these subsequent actions here basically will reuse the elements in the cache, but they won't redo it again and again. They won't recompute the messages again and again. Okay, so it's clear. So are we all good to go ahead with module 6? How about a quick break, folks? Would you like to go for a break here before proceeding to module 6, or shall we continue? Okay, okay. Sure. So pretty much everyone requires a break. So let's go for a 10-minute break here. So right now my clock is showing 11:57. I will come back at 12:07 or 12:08. Okay. I'm going for a break now. Hi everyone, are you all back from the break? Say quickly yes or no. Excellent. So pretty much everyone is back from the break. So let's move on with the discussion for module 6, guys. This session will be quite interesting, especially because we will try to know about the Spark streaming module in detail, and also we'll cover Spark machine learning library packages, both. Okay, let's start for today. The agenda looks something like this. We are going to cover understand Spark streaming and its architecture, then run a Spark streaming program. So we'll also run a Spark streaming program. Then implement transformations in Spark streaming, implement window operations on Spark streaming. So there are different types of operations and transformations which could be applied for streaming. We'll try to apply them. Then checkpointing for fault tolerance. So this is a bit advanced in the sense that how we actually do the checkpointing. What is checkpointing? And then how we could achieve that on top of Spark streaming, and what is the impact or what is the significance of the checkpointing while you write the Spark streaming applications. We cover this all advanced topics as well. Then we'll proceed further. I will introduce you guys to machine learning algorithms in Spark. Then we actually try to understand the concepts in Spark ML package. What is ML pipeline, and then ML in recommendations engine project. I'll take a real world use case, which is basically a movie recommendation system. Then we build the movie recommendations platform from the real world data. So I show you some links where you could download the actual data set, and I will define the problem statement, and then we go ahead and implement the recommendation algorithms within Spark to that particular data set. Okay, so guys, does that sounds like exciting? Module 6. Say yes or no, everyone. Excellent. So pretty much everyone is a bit curious to know about this module. Also, there was a question about Google TensorFlow. I'll try to address that question today. Okay, if we start with machine learning today. Okay, Spark streaming. So folks, how many of you are familiar with the streaming applications or streaming use cases first versus the batch applications? How many of you are not familiar with streaming applications? Let me put it that way. Okay, so let me define quickly the differences between the batch applications versus the streaming applications. So many businesses to drive the operations and even to drive the revenues, to improve the operations and to improve the revenues, it becomes quite significant to analyze the data in a real time, at least in near real time. In order to do that, you might have to capture certain events, logs, or sensor data and analyze them in real time or near real time to be able to improve or drive the positive revenues out of such real-time analysis of the data. So the real-time applications could actually span across the industries. So every industry has got different set of requirements for the real-time data analysis. Just to give a couple of examples before we actually talk about the streaming applications. Say for instance, if you want to manage operations in a better way, for example, a complex system like a well-known example, let's say airport. So you will have different departments within the airport, and each airport has can generate different events like ground handlers or stand and gate, or even departure control system. So you have to analyze all these events, maybe for uh, better scheduling of the uh, crew within the airport, or maybe the better avoiding the delays. So you could actually build different use cases while analyzing these events in real time. And those actually bring a lot of value to the airlines and in fact the service provided by the airport itself. So these kind of things, right, so are applicable for different organizations, different domains. Even if you consider, let's say, e-commerce, for instance. So any e-commerce application might want to analyze the events in real time. What's happening currently at the moment on your application? Is there some anomaly has been existed in any form, either because of the trends? Is there some kind of trend on a particular product? So based on some trends, is there any let's say, is there something messy happening on your application? Maybe if the users are actually going in a different path than you actually see in a regular daily business, in a daily business interval. So to predict that, to actually identify that, and to take action appropriately, it would become essential for you to be able to analyze such data sets in real time, folks. Okay, so that's where all these the streaming applications have been started coming up. In fact, one of the popular streaming applications would actually include the Storm within the Hadoop ecosystem. However, Storm development right now seems to be a bit of a concern, but I think it's still going on. People are still using it in a production environment efficiently. And there is another project called as Apache Flink, which people are now trying to leverage on that. It's a very early, it's still in a very preliminary stage or in a very early stage at the moment. Versus Spark. So Spark in reality does not have a real-time kind of capability. At least it has got near real-time kind of capability. When I say near real-time, it's not really a too long or lengthy interval. You could even configure that into approximately half a second as well. Okay, so at least you are able to see the value of the data at least within half a second or 10 seconds or 15 seconds or a minute. You could configure the interval appropriately. However, Spark streaming module basically is a micro batch environment. The difference is in the micro batch, you capture the data in the configured interval. All those records will be processed as a batch in that particular microsecond interval. Okay, versus the real streaming applications, for example, Storm, there is no concept like batch. Instead, there is something like the moment you get the record, your business functionality will be applied onto that particular record immediately. Okay, there are no batch aggregations involved. However, it just does the straight one-to-one mapping of the functionality of the record arriving into the system. Here, it's a slightly a different path where it tries to apply the operations on a micro batch of records appearing into the system in that small amount of interval. So if you look at the architecture of the Spark streaming module, so this is how something it looks like. So let's see, let's get into the details of it. Satya says, I'm familiar a little bit with Flume. Okay, great. And then Karthik says, work. Okay, sure. So Twitter logs, excellent. So let's have a quick look at this structure. So basically, you have like something called as Spark streaming is an extension. Okay, let's first have a look at this architecture itself. So in the far most left-hand side, you see the ingestion technologies include like the queues, message queues, the ingestion frameworks like Flume, and then HDFS as in the storage. Kinesis is another kind of message queue, and then you have got Twitter as the source. So here basically it is the left hand side, basically it's talking about the sources, or at least it is talking about the ingestion frameworks available in the market today, like Flume for example. So no matter whatever the type here, so basically we consider them as a source system, and you from the Spark consume the data from the source systems in different forms depending on the underlying data source. Okay, so once you connect to the source system and start pulling the data, okay, so start pulling the data out of it within the Spark streaming module. So then you process that data. So this is a pull mechanism. Okay, whatever the code you write in Spark streaming application, so that is going to be a pull mechanism. So in that regular interval I told you, right, like 15 seconds or 10 seconds, whatever that interval is, then in that interval it goes and connects to that source code and then pull the data out of it. Okay, no matter if it's a queue or it's a Flume or it's a HDFS in the storage, it just connects to it and then pull the data. Then once it pulls the data into the Spark streaming module, similarly, similar to the RDD, we have got a typical data structure here called as DStream. DStream stands for discretized stream of data. DStream stands for discretized stream. This is another data structure extensively used in the Spark streaming applications. Whenever you run the operations in the Spark on the DStream, so those operations will be applied at the interval configured within the DStream. DStream is nothing but a pipeline of RDDs. It has got streams of RDD data structures. Okay, so all those RDD structures will be processed by the type of topology you define, the type of functions you define on top of the DStream. So each RDD will go through that function. So to define it in a more detailed way, let me take the paintbrush and try to just draw some kind of layman architecture with which you guys can understand. So let's say if you define a DStream, say DStream, let's call it as a DStream. This is a data structure, right? So this data structure will have streams of RDD. Okay, let's take time on one hand and let's take the streams of RDD on the other hand. So let me say at time interval, okay, 12 a.m. What does it look like? So at time interval 12 a.m. there could be an RDD1 here. RDD1 would have arrived here. So it is then at let's say 12:15 for instance. So if our interval is 15 minutes for some reason, let's say here it's 12. And then here it is, let's say 12:15 for example. So it has another RDD arriving here. So here what essentially you are trying to do, so RDD2, right? So this is RDD2 and so on. You understand, right? So then it continues. So depending on the interval, it continues the number of RDDs being originated. So it will continuously go like this. So now whatever the function you apply on top of this DStream, right? So let's say you apply certain functions, let's say function 1, then function 2. Okay, on function 1 output, you apply function 2. So the output here, let's say F1 output will be input. F1 output is the input for this function 2, and F2 generate some output. Let's call it as F2 output. Okay, and then F2 out is basically an input for function 3, for example, and it might generate the final result. Let's call it as result. So this is how the dstream is been organized. So whatever the functions you apply, let's say function 1, function 2, function 3, it will have the stream of RDDs. So these RDDs arriving into the system will enter into the data structure D stream at that particular interval, and the functions will get applied onto this list of RDDs and then generate some output, and then those RDDs will go through all this in a chain of functions configured to your discretized stream. Okay, coming back here, let's assume that you implement that business functionality in the form of functions and you apply those functions to your discretized stream. So once it goes through the entire process, your entire topology is being implemented, then finally the data, the resultant data could be stored under different data sources, data structure, data bases. For example, it could be a file system like HDFS, or it could be an RDBMS like Oracle, or MySQL, or even PostgreSQL. It does not matter what is the underlying RDBMS. You can just persist the data into the underlying RDBMS, or even you can even persist the data into dashboards. For example, like you can populate the data by creating the dashboards like using Tableau kind of frameworks, or maybe using, let's say, D3 Node.js kind of frameworks. You can directly put the data into those UI. In fact, you can even persist the data into Cassandra as well. So it depends totally on your requirement, folks. So depending on your requirement, the system architecture, you can design what could be your input sources, what kind of functions has to be applied, business functions has to be applied, and then where you have to persist the data or visualize the data on your system. Any questions so far? So Karthik says, what is S3? So S3 is a simple storage service. So what does it mean is, if you're working on an Amazon cloud, Amazon does not have a HDFS. So then what Amazon has something called as S3. S3 is a simple storage service in Amazon. So which basically is kind of a file system or a database in Amazon. Okay, is that clear, Karthik? Sure. So everyone else, are we good so far? Okay, I think some of the concepts we have already discussed. Some new concepts here are basically Spark streaming is kind of a pull module. It works on a pull model. It has some input sources, it has some output sources, and Spark streaming itself is nothing but a D stream, and the D stream is nothing but it's a streams of RDDs. So whatever the functions you apply, those functions are being applied on each and every RDD depending on the interval it actually arrives into the system. Okay, then processed data can be sent to many systems like file systems, databases, and whatever it is, and the streaming converts live data streams into stream batches, and these batches are processed into stream. Same thing, right? So whatever we discuss is the same thing. There is nothing much difference. So in fact, actually sometimes people use both Flume and Kafka as well. For some typical architectures, they use both. They consider both Flume and Kafka. So where Flume basically acts like a source ingestion framework, and then Q acts like buffering your message queue, data sets into the message queue for some time, and then your actual Spark will come into picture. So that architecture you sometimes even refer as Flavka. Flavka is in Flume plus Kafka. Okay, so this is how it looks like. Input data streams arrive into the system. Spark streaming basically connects to it and reads the data. Then it converts it into batches of input data, which is RDDs in our case, and then results will be pushed to the external systems. So Spark streaming context. So guys, did you notice something here? So far, what is the context instance we have been using extensively? Could you all ping me over the chat window? What was the context we have been using extensively till now? The context instance was Spark context instance, and which is the core context object available in Spark. Here, to write Spark streaming applications, you have to use something else or something advanced, which is called as Spark streaming context. Streaming context in short, or Spark Streaming context. Okay, so it is the entry point. I mean, how you write the applications in Spark Streaming module. The core abstraction is Spark Streaming context instance. So your applications have to be implemented using this streaming context instance, which would be considered as streams applications, and defines input sources, streams transformations, output transformations, output operations can be considered as well, and then starts and stops the streaming processes. One of the key things I forgot to tell you is basically the streaming applications will run forever. Okay, they won't be stopped, they won't be shut down, run forever, folks. They continuously processes the data. However, if you decide that you're already done with your application, you can go and manually stop that streaming application. Okay, that's the key part of it. Okay, Spark Streaming dstream. So this is the something which I have already explained, but let me actually walk you through once again. Spark provide a high-level abstraction called as discretized stream, representing a continuous stream of data that we are all aware of. A dstream can be represented as a sequence of RDDs. So this also I told you, right? So it is arranged as a sequence of RDDs. So Spark Streaming, it has this dstream, and then each batch at time 1 is basically RDD at time 1. Then batch 2, time 2 is considered as RDD at time 2. So okay, it's similar to what I just drawn in the Paint using Paint window. Then streaming word count. So now that we understood about the Spark Streaming module, let's first write our first application. Let's write a first simple application on Spark Streaming word count. So in this case, val spark conf is equal to new Spark configuration instance dot set application name. So folks, I'm trying to set the application name as network word count, and then new streaming context. I just pass the Spark configuration instance to it, and I also have to define the interval. See this. Is there any difference while instantiating a Spark context versus streaming context? My answer is yes, there is difference. What is it? You are passing the Spark conf as is. Additionally, you have to pass one more parameter, which sets the actual interval of your application, of your streaming processing. So see here, what is the interval in my case? It is just 1 second. So you can say it is pure, it is almost a real-time application only, but since we have to keep that difference between the real-time and then the actual mini or micro batch thing, so we still call it as a micro batch system. Okay, because you're applying some operations on at batch level, not at a record level. Okay, that's why we call it as micro batch system instead of calling it as a real-time application. Then after instantiating the Spark context, streaming context, I just say socket stream. So this is because I'm going to write a simple streaming application now, where what I will do, I will simulate a streaming environment. How am I going to simulate that? Using this something called as netcat. Are you familiar with netcat, folks? It's just like network some network actually. Cat means you're just printing some messages, right? So netcat basically is an utility where you can actually define something like a client and a server. So server as in which actually produces some messages, client as in which consumes the messages from the server. So I run that environment now in my Linux, in my VM, and I create a server and the client. So basically client here is my Spark application. The server is the netcat where I try to produce some messages to my streaming application. And by doing that, what I will also do is every 1 second, I try to do the word count for each and every message appears into the system. Let's say if I pass 10 messages in 1 second, it just does the counting of 10 messages in 1 second. Okay. Then just I'm saying lines dot flat map of, I'm just splitting that using space, and then I get the words. I just say count operation. So this is basically word count method, right? So which we are already aware of. And then finally that it prints the word counts onto the console, and it just continues with the same operation. It just awaits forever to expecting the inputs from the server. Are we good so far? Any clarifications, folks? Are we good enough on Spark streaming and how the architecture looks like, what happens internally? So we can proceed further and run this word count program first, and then we run another example as well using the Spark streaming module, and also it's kind of bit advanced later where we try to see how we can recover from failures or errors in the Spark streaming application using the concept of checkpoint. So Karthik says, what is a socket text stream? Don't worry about it. I'm going to show you that, okay? Karthik, in my program. Then Ram says, so every minute whole logic will run. Absolutely, Ram. So every minute the whole set of logic will run. Then Karthik says, what it does. Okay. So Karthik, just wait on that. I'll explain you while writing the code itself, while executing the code. Then so Ram says, is it every second or every minute? So basically it's, yeah, whatever the configured interval, right? So here it is second, so it runs every second. So if you configure it as minute, it runs for a minute. It doesn't matter. It basically, it runs for every scheduled interval. That's what it means. So socket text stream. So basically, this is a method actually available on streaming context instance, socket text stream. It basically binds to this socket. You know the socket programming? So basically you create a socket and then you listen to that socket, right? So here I'm actually creating a socket and listening to this port. So this is like socket applications programming. So whatever the messages appear into this socket will be streamed into the Spark streaming module. Okay. So what I'm going to do now is basically I will create a netcat connection server, and then I'll just start sending the message using netcat. So those netcat messages will be consumed by my Spark application using that this method called as socket text stream. And then count do the word count and then print that onto the console. Okay. So if you are all good, I'll proceed with the execution of the program. Before that, let me walk you through the code first. So Anand says, in streaming, how can we maintain the output? So Anand, there are different ways to do that. Basically, like for instance, most of the cases, right, the output is going to be the NoSQL databases like say HBase or say Cassandra kind of databases. So you just map the whatever records are aggregated records into HBase or even Cassandra kind of databases. Okay, if it is going to be, let's say, HDFS for instance, then it could be a bit difficult to manage because you can't afford to write the data every second or minute separately into HDFS. Then you will end up writing too many files. So then there are two ways to handle. Either you write another job on top of it which does the aggregation of all that small files generated every hourly basis and purge the small files. Otherwise you can actually have another job which basically triggers only at let's say every 1 hour, which does the persistence of the job data onto the HDFS. Okay, there are different ways to handle it, but the popular way to do that is basically to have a NoSQL database. And NoSQL databases, you know, right? You can do the inserts as well to the NoSQL databases. Either it's HBase or either it's Cassandra or whatever it is. Are you good on that? Anand and everyone else? Okay. Shravan says, I would think it will help how big data works to capture, store, analyze, and visualization. Shravan, am I missing something from your question? What is your question? I couldn't understand your question. Could you please rephrase? Shravan, if you have your mic, it's better I will unmute you so you can directly ask your question. I think you're trying to post some bits and pieces which I couldn't understand. Okay, Shravan, so better go and I'll unmute you. Just give me a minute. So Shravan, what I'm going to do, I will unmute you and I will mute myself so there won't be any echo of the voice. Shravan, please go ahead with your question.
Hey Mahesh, thanks for giving mic. I would think like most of the people they will understand big data, why we are using, right? So if we explain like how we, I mean, the streaming is like mainly capture basically how we capture data from various sources like Kafka could be a file or or MQ or RabbitMQ. So this capture is basically part of streaming. And once you have this streaming done, right, then you will be storing it to some kind of big data store. Probably could be Hadoop or Cassandra or like any other NoSQL data store. Then how you apply. I mean, we are not going to discuss anyway analyzing the data and visualization at this point. But I think basically these are four parts, right? So capturing data and storing data, applying analytics, and visualization. I mean, these are the four steps usually any big data applications they. I mean, these are steps applied on any big data. That's what I wanted to let you know.
Okay, so basically I understand, and thanks for sharing your experience in terms of the high-level operations what you usually typically perform in any big data environment, in terms of like capturing the data, I mean ingesting the data, and how you actually store the data, which is data storage, and how you do the curation of the data, and then which in the sense part of analytics again. So how you analyze the data, and then how you uh, finally visualize the data. So what basically Shravan is trying to explain is basically what kind of top phases involved in any typical big data environment. So yes, true. In a way, so these are at a high level, these are the typical steps performed on pretty much any big data applications. So, however, if you consider, right, like for instance, say streaming applications, it could be slightly different approach. So, why you actually first capture the data from different sources. So, it could be any source. For example, it could be the sensor data, which could be directly captured from different sensors, or maybe some third-party server which sits and which actually captures the sensors data, and from that you can actually stream the data. It could be access points, for example, where you actually capture the logs from the access points. It could be any end host device from where you capture the data, which is like ingest the data. And then in streaming applications, what happens is you basically stream the data straight away, and you first try to do the analysis of the data or processing of the data. Not really, it could be analysis, it could be processing. So let's call it as analysis for the sake of simplicity. So you analyze the data over the Spark streaming, I mean any streaming modules, and then you consider the storage, and then the visualization, or even you analyze and then directly visualize the data. So typically that's the difference in batch versus real streaming applications. So there the storage part does not come first, rather the analysis part comes in the beginning, and then the storage part will be considered in the end, or maybe the visualization. Okay, so is that fine, Shravan? Anything else? Then Satish says, do we have to do any cleanup of the streaming RDDs for maintenance? Absolutely, Satish. So as I was mentioning, so in fact, once you capture the data, what's the first step on the big data systems is basically you curate the data, which is like data curation layer, right? So it doesn't matter whether it is on the streaming module or whether it is on the batch environment. In both the environments, you have to still curate the data first. It could be like removing the duplicates. It could be filtering out the data which is not meeting your standards or something like that. It could be anything. And then Anil says, are you going to cover Spark SQL area? So definitely, Anil. We have Spark SQL for tomorrow. Okay, so you have to, we'll cover that in tomorrow module. So if everyone is good, shall we proceed with the program now? So shall we discuss about how the program looks like for this? Okay, it's here. Let me see. I think this seems like it's not the streaming one. Let me go to module 6 here. Okay, so folks, I'm in module 6. I have created something called as network word count. So Ajay says, could you share your experiences in terms of filtering? Okay. So Ajay, is your question specific to curation or is your question specific to filtering the data? Okay. So if your question is specific to curation, right? So as I was just explaining, various domains, if you consider, let's say, for instance, healthcare industry. So it is quite possible that you get the duplicate records because of the fault within the source systems itself. Okay, it would become critical for any application to actually remove such duplicate records before it gets into the system for various reasons. It could be as simple reason as to avoid the lot of storage, to rescue the storage, or it could be to avoid creating fault aggregations in the further processing layers. So it becomes critical to be able to remove such duplicate records. So you have to implement such a duplicate removal strategy within your application itself, so that you can actually consider it as a curation layer. But normally what curation is, it basically depends upon the quality of the data you get into the system. So apparently, right, many source systems, if you consider a wide spectrum of big data, you get the data from different sources. It could span from 10 sources to hundreds of sources as well. Considering that kind of hostile number of or hostile environment where you get the data from different sources, they may not adhere to the actual format being specified. Let's say you expect CSV format, but you end up getting some kind of TSV format data. You expect some text format, but you may get some binary data. So if you're expecting some fields within your each row or a log, and some fields are actually missing in your log, so you can't afford to actually move such kind of non-quality data, right, into further processing. So that's where you try to filter out such records upfront before they cause any trouble to your processing layer. So this kind of data quality checks could also be considered in a data curation layer. Azay, does that help anyway? Okay. So Karthik says, what are the most commonly used file formats? So typically it depends, Karthik. So far most of the big data applications in general, they basically talk about unstructured data, but that part is not really there. So mostly when you say unstructured data, that could be in text format. So text also could be considered as unstructured data. But in wide, let's say in different domains, what I personally notice is data is always having some structure associated with it, even though we call it a semi-structured data, especially because because of the irregularities within the data. So we actually call it as, for example, semi-structured data, but at least at the end of the day, it has some structure associated with it. Typically, in terms of formats, it depends on the source system and how you configure those source systems. It could be like JSON, CSV, TSV. So some text file format only. Or maybe sometimes it depends. You can even get the binary format as well, depending on the underlying source system. Then you have to have a parser layer. So even parser also you can consider as the first step within the analysis part, or even it could be considered as the part of curation layer to be able to parse such binary formats and then other stuff. Karthik. Excellent. So let's make a move here. So in the network word count program, you can see here, I'm just trying to import a lot of APIs. So in the sense, I'm importing streaming API here, and then configuration from Hadoop, and then file system path. Okay, I think why am I doing that? Because configuration, I'm not using any configuration here. So I can actually remove this because I'm not using this here. So I can remove this stuff here. Okay, but overall what I'm trying to do is basically like importing the streaming module and then streaming context. So I think since we have already done that, let me remove this as well. That's it. So what I'm trying to do here, instantiating the Spark configuration instance by setting the name as network word count, set master as local, and then pass that Spark configuration instance to Spark streaming context. Create the Spark streaming context instance. Then Spark streaming context at socket text stream. This is a method or a function within the streaming context which basically listens to a socket at this port. It creates a socket and listens to this port on that server machine, let's say on that machine where this program is running. And then lines.flat map off. So flat map basically splits the lines, and then based on the space, then we'll collect all the words into one single RDD called as words. Let's say if there are 10 lines get split based on this, and then instead of creating each record separately, it just maps all those values to the words RDD. So once you get this words RDD, then you are saying words dot map of x, means x comma 1, then reduced by key underscore plus underscore, which is basically doing the word count operation, and then print, and then start the application. So I'm just printing it onto the console. All the word counts will be printed onto the console, and then Spark streaming context at start off. So this basically starts the streaming application, and this program will never stop automatically. So you have to stop it manually. Then Spark streaming context at await termination. So this runs forever, folks. Okay. So now that we have this code ready, So I think Karthik is asking what is this local off to. So Karthik, do you forgot about this already? So we discussed something, right? That you can run your applications in the local mode as well. So standalone mode is different. You can also run the application in local mode where your Spark runs on local machine by using the number of threads configured to it. Here, the number of threads is 2. So it just uses 2 threads to run the application. So this is not Spark cluster. This is not the Hadoop cluster, but it just runs on a local cluster. And since we are just reading the data from the netcat, right? So that's why I prefer to run it on a local machine. So Anand says, why are we maintaining the Spark streaming context at start at last? Because you have to start this application, right? So in order to start this, we have to invoke this start method on the Spark streaming context. So at this stage only, the Spark streaming context program will get executed, will get initialized and then starts. And the whole topology will run forever. So whatever this program, right, this runs forever at this stage. Ajay says, I assume we have netcat on your VM. Yes, don't worry about it, Ajay. So I already been using extensively, right? So it already has it. Okay. Let me do one thing first. Let me build this project. Oh, I'm sorry. I just closed it. So the project has been built successfully. Let me now move the jar file. So I'm copying the jar file onto my VM and I'll quickly run the program. So the program is what? It is network word count, right? Is network word count is. So I have to first start the netcat. Okay, otherwise this program will throw the error as who is that? I think as I said. So first let me run the program Anand and then I'll come back to the await termination part. Okay. So I'm opening other terminal and let me start the netcat here. So the netcat has already started. Okay. Now that I already have this here, so let me run the program network word count. Okay. Network word count, but what's the package? I think there is no package, so I can directly run this. See here, the program has started and it will run forever. Okay, so it will not stop at all. So it even says that connected to localhost, whatever this port. Okay, now let me go back up into the netcat screen and let me ping saying that welcome to say Edureka and then welcome to Spark and then say welcome to Hadoop, for instance. So I'm just printing out those. See here. Already it has started printing out the messages also, word counts. So whichever the message comes in that particular interval, they get processed. Like here. So it makes sense here, right? The word count actually makes sense here. So there is no output at all because there is no more messages here. No more messages. No messages, for instance. Okay. The next iteration will print the word count on the console. Okay, see here, no more messages. Okay, like this it continuously will print. Okay, now that this program is running here, right, continuously, then why? It's because here we are actually saying we are starting the application and we are saying await termination. Await termination as in it just waits for the user to terminate that program. Okay, wait for someone to terminate this application manually. So it does not have any built-in mechanism like, let's say, run for 10 hours and stop. So nothing like that. But it's just waiting for the user to manually interrupt this program. So how can I stop this program? By saying Control C. When I said Control C, the program got terminated because it was awaiting for the user signal to be able to stop. Does that make sense, Anand? Is it clear now? Karthik says, so at least, so the least configurable time interval is 1 second. Not really. You can even configure less than that, Karthik. Okay, 0.5, something like that you can do. And there is milliseconds also. You can define milliseconds as well instead of seconds here. Okay. We're all good now so far. Shall we move further? Okay. So methods are pretty much similar. Map function, it's the same story, filter function. But the difference is here, when you say map, return a new dstream by passing each element of the source dstream through the function. So here, as I shown you in this paintbrush, right? So at each interval, you have got an RDD here. But your function, even if it is map function, that is at this dstream level. Let's say if you're applying a map function here, let's call it as a map. And this map function basically is taking this dstream and generates another dstream. Okay, it'll be a new dstream here, which pretty much will look like this. Okay, I'll just copy paste this one only rather than creating one. So map, taking a dstream, generating a dstream, again different RDDs underlying RDDs. So it does the builder function also same way. It creates a new dstream which has a function, and then flat map. This is slightly different. Flat map basically returns all the results. Let's say for someone the difference between map and flat map, right? So here similar to map, but each input item can be mapped to 0 or more output items. For example, like this. So if you got, in our case, what did we do here? So we did this on lines, right? What it does is like this. Let's say you have got 3 lines. Welcome to Edureka, welcome to Spark, and then welcome to something. Let's say Hadoop. So if these are 3 lines, then usually if you say map will actually return one-to-one mapping. Okay, so it might split. This record will be something like this. It will be tuple. Okay, breakdown. Welcome is one word, and then 2 is one word, and Edureka is one. Like this, it will give a breakdown, and then we'll assign this each tuple to again your resultant RDD. But flat map, what happens is it will just accumulate all the outputs into one single array or one single collection. Let's say again welcome, then 2, then Spark, something like this. Okay, it just accumulates everything, flat map, and then it returns that result. Yeah. And then flat map is this that one, and then reduce function also pretty much does the same thing. Return a new D stream with the single element order. It is the same way how the reduce works. Reduce by function by key also is the same. Count basically returns the count operation, and then the join operation is also the same thing, folks. Okay, pretty much this behaviors does not change, but these will be applied at the D stream level. Only the new thing we learned is flat map. So streaming word count demo we have just seen. The window operations. So let's try to understand about the window operations. So Satish says, okay, so guys, are you able to hear me, or was there any problem with my audio? Are you all able to hear me? Okay, excellent. So I think looks like there is some issue from Shakti side. So Shakti, is it okay now? Are you able to hear me? Okay, sure. Okay, so Satish has a question here. Please listen, everyone, folks. It's very interesting. If streaming program dies for some reason, shut down for some reason, it goes down. It could be any reason, right? Because of the improper data, your program crashed and then it goes down, or maybe due to some issue within your CPU, something like that happened. Okay, and your streaming application went down. Then how could you recover the state? Actually, what you should do, right, Satish, there is a concept called as checkpointing. So you have to just wait for some more time. Basically, what happens is every time there is a record processed while in the streaming phase, that data will be persisted somewhere in the disk. So if the program crashes, it at least knew that where exactly this program has crashed. So it can try to recover that information from the data available within the disk versus the data available within the source system. Okay, based on these two things, it can try to recover from exactly the same phase. And there is a program also which we will be discussing in a moment. Okay, Satish, is that fine? Then Shravan says, could you please explain, could you please show how do we deploy it as a topology into Spark cluster with, let's say, 2 executors. So Shravan, just waiting for another program. Okay, so that will be the most complex kind of program. So where we try to do, we can do that. Shravan. So guys, now that we have covered too many topics for today, right? Are we all good? Shall we proceed, or shall we take a logical break here and then reconvene again tomorrow? Folks, shall we continue or shall we take a break here and then we'll come back tomorrow? Just say stop if you would like to stop, or say proceed. So I think there are many requests to stop the session, and there is one request from Shushma to continue. I think Sushma, since there are many requests to stop, so I understand why they are requesting that, because of too many topics we have covered for today. You also might need to go through and then get some practice on top of this things we have discussed. So let's take a break here. Okay, then we reconvene tomorrow. Before that, just one more question I would like to ask with everyone before you guys drop off, folks. Guys, can we take one more additional session tomorrow? Is it okay with you taking additional session tomorrow in the morning time for people from India, and it will be evening probably for people from States? Is it okay or is it not? Say okay or say not okay to take one more additional session tomorrow. So there could be 2 sessions tomorrow. Okay, okay. So I think there are many folks who does not want it that way. Okay, sure, no problem, no worries at all. Okay, let's not do that since many folks are already a bit worried about it. So don't worry. Okay, let's do the normal class tomorrow as is. There won't be any additional session. Whatever the pending topics, right, we'll cover it in the next week then. Okay, so we might have to extend for the next week. You all understand, right? No worries, Shravan, Anil, Reggie, and everyone else, Megasham. Okay, don't worry about it. We can start from tomorrow. No, we do just as usual session. There won't be any additional session. So Anand has a question here before we wrap up. Is there any difference in the RDD functions obtained from text and RDD from streaming? Not really, but the functions you apply is not at the RDD level here in streaming applications. It is at the dstream level. Okay, there at the RDD level. Anand. So Ajay would like to speak to me. So let me unmute Ajay for a moment. So any further questions, please feel free to ask me now. I can take your questions here. So Shravan is requesting to have an example with Kafka. Don't worry, Shravan. I think the next example we are going to see is with Kafka only. Okay? That will be tomorrow. I'll show it to you tomorrow. Ajay, please go ahead with your question.
Mahesh, thanks for taking my question. In the last session, when you discussed about the sequence file example, the commands are not available for us. At least I do not know where to get them from, except from the presentation. And the presentation document is read-only, so I have to manually type those commands or request the support guys. It takes time to get it from the support guys. It would be great if you can just provide us in a place where we can copy it immediately after the class or during the class. Like give us a URL where we can copy all these commands. Thanks, Mahesh.
Okay, Ajay, so I understand that. So let me see where I have written those commands. Let me do it right away. Otherwise, I'll just forget about it. So it's very hard to recall. So let me do it here. So commands for module 4 probably. This should be the one. Okay, it's here. Let me just paste this, okay, to you all. These are for the cache, and then this should be for sorry. So did you all get the commands? Any further questions? Anyone else? Venkat has a question. Venkat is asking about the data frames and DAGs and IS. Okay, so Venkat, we haven't even started about the Spark SQL, so you have to still wait. I really suspect tomorrow also probably we may not be able to venture into SQL, or maybe at least the basics into SQL probably we can venture tomorrow. Depending on the time availability and all. So hopefully next week we can cover that. Venkat. Any further questions? Anand, Ajay, Venkat, Karthik, anyone else? Excellent. So if there are no questions, so we can take the break here. Then we come back and read tomorrow in the same time. As I said, if something is in balance, we can actually take it in the next, we might extend it to the next week, okay? Sure, no problem, folks. Okay, I hope you guys have enjoyed today's discussion as usual, and try to complete all your assignments, and then we'll reconvene tomorrow. Please do not miss tomorrow's session. It will be quite interesting. We'll cover the advanced topics in streaming, and also we cover the machine learning library package, and also probably we cover the Spark SQL. Okay, these are the 3 modules I'm going to cover tomorrow, folks. Okay, bye for today. Okay, have a good night and have a nice day.